Good morning, humans. So welcome to third lesson of our quarantine series of this amazing end of York session. So after today, we'll be 1/3 of the way done of our quarantine sessions. So yay! Only 2 more weeks left. I hope you all are as excited as I am to just be done. But we're still unfortunately not done. We got things to learn. York is making us do everything anyway. And so a couple announcements before we begin. So, announcements, as always, because things change every 2 seconds. So it was, someone suggested we use CrowdMark. Actually, a couple of people suggested we use CrowdMark anyway for the exam. I was mainly worried because I didn't know if it was forcing you to print, like what the specifications was. I was really worried because I was like, most people don't have printers. Like, how is that going to work? And so I talked with CrowdMark. I talked with a few students who have been doing CrowdMark exams in other classes, and I'm more happy with it now. But what we're going to do, you probably already saw this email. There's going to be a CrowdMark practice test. CrowdMark practice test, which isn't really a test. It's basically a way for you to test whether, or yeah, I guess it is a test, but not in a test in another. Anyway, in order to test that you can actually upload everything that you want into CrowdMark. So this is basically making sure that you can do everything properly in CrowdMark and there's no issues. So basically, you should have already gotten an email from CrowdMark. I announced this yesterday. And theoretically, in the email, you should have received something that looks like this, a CrowdMark practice test. And so basically, what I just want you to do is do one of these 3 options. Either print it out if you do have a printer, fill in all the parts, and then send it back through CrowdMark. Or if you want, you can just do it on like normal paper. Like, it doesn't matter. You don't even have to copy the questions. So no copying of questions. You just say number 1, here's the answer. Number 2, here's the answer, etc. And then the third option is to kind of do what I do, where you have a tablet. So you should be able to just download this PDF theoretically. And then you can just write on it with a stylus, save that either through screenshots or whatever. And then you submit that. And so this is basically getting you used to being able to upload and everything into CrowdMark, and also make sure that on my end, I'm able to actually clearly see things, that everything is going to work properly, etc. So we're going to be using this. As you can notice, you get bonus points if you do this. So you get 1 bonus mark on a midterm 2 if you do this. So you get an extra point just for uploading a file. Do it. It's 2 seconds. The 3 questions, don't worry. I don't actually care about the answers. Number 1, you can even lie. What province is the capital of Toronto? That doesn't even make sense. Capital of Toronto. I meant on Canada, but whatever. See, the question doesn't even make sense, but who cares? And we're going to say it's in BC. Number 2, this one's worth, the last one was worth 2 billion points. So hopefully I get that one right. Question 2, basically I want to test what happens when we have a box drawn like on multiple pages. So I'd like you to draw a box. So here's the top of a box, and inside we're going to draw a little picture. So here I'm going to have like a little tree, and then I'll finish the picture on the other side. So on the second page, we'll finish the box. And then here's the bottom, here's the bottom of the tree. And then here's us lounging under the sun, pretending we're outside. And then question 3, just how many oxygen atoms are there in H2O according to me on the very first day of class? If you were there, you probably remember it's not 1. So I'll let you figure this out yourself. So do this. Send it over to through CrowdMark. Try to do it sooner rather than later so I can double check everything is okay. So if things don't work out, we can fix it sooner rather than later. I don't want it to be Sunday night and I can't get a hold of CrowdMark for them to fix whatever issues are happening. So please, 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 please do this soon. Yeah, I think that's it for announcements. Hopefully there's not going to be other announcements coming up. There we go. And then where is the practice midterm? There we go. And so what we're going to go over next is the practice midterm. Note that this lecture is going to be extra long, mainly because I actually want to go over the entire practice midterm, which is going to take longer than the hour, since we've already kind of gone over a few things. I will still break this up into multiple parts. What I would recommend is first try it yourself. So I would actually recommend stop the video, try this practice midterm yourself. I know I gave it last minute, but I've been trying to make this as quick as possible. I spent literally all of Tuesday and half of Wednesday, because the other half I was with you all, working on getting the midterm set up. It's taken a lot of time, so I didn't have too much time to do it. So try it, pause it now. And yeah, so I'll see you back in like a couple hours, or Saturday or Sunday or whatever, when you get here. Okay, so let's talk about the practice midterm. Let's actually do it. Fuck, I should have talked about this before. So note that there's no instructions here. There will be instructions on the midterm itself. Please follow them. They're just going to be basically whatever feedback I get from the CrowdMark stuff. So make sure you're doing that properly. Also, the questions that you're seeing here, they're definitely going to be easier than what is on the midterm itself. And that's because I need to make sure that these are okay for everyone to do. Like, because you're doing it at home, you have a whole week to do it. They can't just be super like on easier things where you're on a time crunch, right? They're designed to make you think a little more. So they are a little bit harder. I tested all of them. They do all work properly. They all are doable within a nice time frame. So it shouldn't be too much more work. They're just only slightly harder. Also, there are probably about 25 different versions. 25 versions of the exam. Like this, you all can't really copy off one another, since I won't be there to kind of watch over things. So just a warning, if you do ask your friend for like, hey, can I just copy off you? If you do copy, more likely than not, you're answering a different question. I will notice that, and you will get 0 points, and we might have to talk about disciplinary action on that. And I don't want to take it there. So please don't cheat. Also, I had another point. Blah, 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 blah. Oh, yeah. So instructions as to, yeah, no, that's it, actually. No, okay. So let's start. The first question is obviously a question that we should have expected to see. And these are limit questions. And so generally when you see a limit question, you're going to assume this is going to be a L'Hopital question, yeah? And so what's the first thing we do with L'Hopital is we test out our numbers, and we see whether we're going to get one of the forms that we talked in class. So looking at number 1, if I plug in 0, I would get -2 times 0 plus 1 to the 1 over 0, right? So this part would give me 1 to the infinity. We hadn't gone over this in class, which is why actually I'm doing this on the midterm. But this is one of the forms where we can use L'Hopital. Remember, we can't use L'Hopital unless it's 0 over 0 or infinity over infinity. But we can convert this into one of those forms. And so we will go over kind of how to do that today. Let's look at the next one since we're already here. If we plug in 0 here, we get 3. I guess I shouldn't put 0 is equal there, times 0 over 3 to the 0 minus 1. So we get 0 over 1 minus 1, which is 0 over 0. So here we can use L'Hopital. And then finally, here we get minus, I don't know why the computer automatically does this, but whatever, minus 0 minus e to the 0 plus 1. So here we get, and then 0 squared, so we get minus 1 plus 1 over 0, which is just 0 over 0. So in these two, we can use L'Hopital. Use L'Hopital. I guess I shouldn't write this here. Let's erase this. And we'll do these later. So let's start off with number 1. And then we'll go over kind of how to do these problems, right? One at a time. So number 1, we're going to start off with limit as x to 0 of minus 2 to the x plus 1, 1 over x. And so this, we can't use L'Hopital's rule yet, right? We don't have 0 over 0 or infinity over infinity. So what are we going to do? We're going to try to convert it into one of those. So what's the first thing we notice when we see something like this? We notice we have some function to the exponent, some other function, which basically what this means is we're probably going to want to use our natural log method. So what we're going to do is we're going to set this equal to L, and I'm going to take the natural log of both sides. So maybe I should do this slowly so people can see. There we go. So here we have natural log of L is equal to the natural log of limit x goes to 0 of minus 2x plus 1 to the 1 over x. Here I can switch these two. Yeah. And so we'll get limit as x goes to 0 of natural log of minus 2x plus 1 to the 1 over x, all of that. By rules of natural log, I can bring this 1 over x in front. And so this is going to be equal to the limit as x goes to 0 of 1 over x times natural log of minus 2x plus 1. Okay, so what are we getting here? Let's see. If I plug in our numbers, the limit here, I get natural log of 1, right? Because this is going to go to 0. So we get natural log of 1. This is equal to 0. And then x is going to 0. So we have 0 over 0. Therefore, we can use L'Hopital. That makes us happy. Oh yeah, if you add happy faces or in the exam, I am more than okay with that. I like drawings. I like fun little things. So add those in if you so feel. So here, we can take L'Hopital's rule, right? So what are we going to do? We take the derivative of the top. So what's the top here? We have this little top part. Here, we have natural log, sorry. We have the natural log of minus 2x plus 1. And so what does this equal? Natural log, we've already seen a few times. We take 1 over whatever is inside. And then we multiply by the derivative of the inside. Here, the derivative of the inside is minus 2, right? Because we have minus 2x plus 1. The 1 goes away. The minus 2x becomes minus 2. So here we have minus 2 divided by minus 2x plus 1. And then what's the derivative of the bottom part? The bottom part is just x. So the derivative is just 1. So therefore, by L'Hopital, we have that the natural log of L, so I'm just bringing this part here down. I'm bringing this down. Remember, these are all equal to one another. I don't know if you can see this stylus. Hopefully, you can see the little dot. So I can bring this down. So this is equal to, down here, is equal to the limit. No, I don't want it this way. Rewind. We're deleting this. Gone. And then we're doing this again. So I'm going to go from here. I think this makes more sense. Sorry about this. So I take this part, what I had before. And so by L'Hopital, I can make this transition, right? So I still have the limit as x goes to 0 of whatever's on top. What do I have on top? I have minus 2 divided by minus 2x plus 1 divided by whatever I have on the bottom. So what do I have on the bottom? The derivative of x is equal to 1. So what happens here? This is now equal to, I can bring this up, is equal to the limit as x goes to 0 of minus 2 over minus 2x plus 1. So here we're using our domain information. So remember week 1, you're going to need to know your week 1 material as to what is the domain. And also I think week 3 where we talked about where these are continuous and differentiable. So since this is continuous everywhere on its domain, and its domain is every real number except for, I think in this case we want 1/2, right? Because 1/2 will give me, for 1/2. Therefore, we can take the limit. We can plug in, right? So if you want to plug in, you're going to want to use our week 1 and week 3 stuff. So someone asked the other day what the material is going to cover. And this is what I mean when I say we're going to use all the material. You need to remember week 1 as well. You need to remember week 3 or else you're not going to be able to properly answer. I am looking for this. Yeah. And so we can plug in, which means this is equal to minus 2 over 0 plus 1. So we get minus 2. So what is minus 2 actually? So we have, therefore, the natural log of L is equal to minus 2. That is a horrible minus sign. Right? But what we're trying to figure out is L, right? We're trying to figure out this limit up here, right? Let me go back up a little. This is what we're trying to figure out. So I need to actually take the exponent, right? So, or exponential. So I take e to the natural log of L. This is just equal to L. This is going to be equal to e to the minus 2, right? Natural log of L is equal to minus 2. So this is equal to our limit. This is what our limit equals. And that is part 1. I am almost out of room. Bananas. Maybe putting 3 questions on 1 page is not good. Okay, I will fix that for the exam and break this up into multiple parts probably. Maybe do 1 question per. We'll see. I'll figure it out. Okay, so we'll do that. What I'm going to do next is let me actually... we'll go out of here and I'll just open another page to be able to do, actually it doesn't matter, y'all can, okay, so if you pause here if you need to look at this more, if not I'm going to delete it all and we'll start off the next one. So 3, 2, 1, it's all going away. Bye. Okay. So I want to keep that for now. This is gone. That's gone. And so we've already done 1. So let's look at number 2. So number 2, we take the limit as x goes to 0, 3 to the x over 3x minus 1. So here remember when we plugged in, right, we get 3 to the 0 times 0 over 3 to the 0 minus 1. So we get 0 over 0. And so we can, therefore we can use L'Hopital's rule. So let's try this. So this implies that the limit as x goes to 0 of 3 to the x over 3x minus 1. We're going to need their derivatives, right? So let's look at the derivatives. D dx, 3 to the x times x, and the derivative of the bottom. A lot of times on the quiz, people were saying, oh, we need the derivative of the quotient. That is wrong. you need to take the derivative of the top and the derivative of the bottom separately. We do not, this is no longer a fraction when we're looking at L'Hopital. So let's look at this derivative. So we take the derivative, this is the product rule, right? So we take the derivative of the first part. So we have natural log of 3 to the x times x plus the derivative of the second. So we have 3 to the x. The derivative of x is 1. So that's it. The derivative of the bottom one is even easier. This is just natural log of 3 to the x. So these are things we've already seen in class. And if not, you have these notes. Look it up online. Right? There's a reason you can do these at home. That's also a reason why these are a little harder, because you do have access to any resource you want, yeah? And so looking at this, let's do this. So we have this is equal to, we keep this top part, so we have natural log of 3 to the x times x plus 3 to the x over natural log of 3 to the 0. So here, if you plug in, you're going to, not 0 to the x. If you plug in, you'll notice that you don't get 0 over 0 or infinity over infinity. And so we're going to want to plug this in. But first, before I plug in, I need to state why I can plug in, right? So here, we can plug in since the function is continuous everywhere. And since the natural log of 3 to the x is strictly greater than 0 for all x. This is for all. And so we can plug in because it is continuous everywhere, right? These are using week 3 continuous rules that we kind of went over. And so here I can plug in. So I have natural log of 3 to the 0 times 0. So this is just going to go to 0 plus 3 to the 0 over natural log of 3 to the 0. So here I cancel this prematurely. I should have done it now, but it's okay. This is canceled. So here I have 1, 3 to the 0 is 1, divided by natural log of 3 times 1. So this actually ends up being our solution, 1 over the natural log of 3. So that's good. Okay. That was easy. I'll give you 3 seconds before I get rid of this. 3, 2, 1, bye. Okay, yeah, we get rid of this, and then it's okay. Question 3. So let's look at the limit as x goes to 0 of minus x minus e to the x plus 1 over x squared. What I'm going to do is, since we're working with derivatives of top and bottom, I'm going to actually put this minus upstairs, and I'm just going to multiply through, just to make my life a little easier. So I have my e to the x minus 1, just to make everything a little easier. So let's plug things in. So plugging in here, I get e to the 0 minus 1 over 0 squared. So I get 1 minus 1 minus 0 minus 1 over 0. This is just 0 over 0. So we can use L'Hopital rule. Therefore, we can use L'Hopital rule. Therefore, we can use L'Hopital's rule. And therefore, this is equal to, we need the derivatives. So let's look up the derivatives. E to the x minus 1. And I need the derivative of the bottom, x squared. So this is just e to the x minus 1. And this is just 2x. So here we have this is equal, so we have limit as x goes to 0 of e to the x minus 1 is equal to x squared. This is equal to limit as x goes to 0 of the top part, so we have e to the x minus 1, divided by the bottom part, which is just 2x. But here, if I plug in again, notice what happens. So you can actually see that this is not going to work, right? Because we have that 0 is not in the domain. If I plug in 0, I get something divided by 0. So I automatically know I can't plug in. It's not in the domain. But what happens if I am not stupid, but I do the stupid thing and just plug in anyway without testing things? What I get is 1 minus 1 over 0, which is 0 over 0. That means I can use L'Hopital's rule again. Therefore, I can use L'Hopital's rule again. One thing to notice, and I'm going to do this in yellow so you see, notice how here I am not putting an equal sign. And that is because these are not equal, right? So when I'm plugging in here, and this is something to note, notice how I did it here as well. There is no equal sign. And that's because when I'm testing for 0 over 0, I'm plugging in things, but they're not necessarily equal, right? So this is why the equal sign is a big deal. This is why for the quiz 4, I had, that's one of the reasons for one of the parts I removed the equal sign. So you can notice that this equal sign is a big deal. It's not just something to throw around lightly. Not everything is equal to one another. And so you need to be able to differentiate, distinguish between when you have a limit and when you don't. And so here I'm distinguishing it by, in my case, I can use different colors. If you can't use different colors, put it on a different line. So for example, maybe we can pretend. So if I didn't have a different color, what I would do is, this is easier because I can move things around. Tablets make life easy, I guess. And so what I would say is, if we plug in even though we can't, and then we get this, right? So if it was all black, I'm just going to do this, change to all black. So if it was all black, this would be appropriate. Right, so I'm letting people know that I'm not actually plugging in and I'm testing it out. So this is something to take note of. This is something we're looking for. So here I need to use L'Hopital's rule again. And so let's look at the next derivative. So I need e to the x minus 1. And on the bottom, I have 2x. So on top, I have e to the x, right? The minus 1 disappears. And on the bottom, I get 2. So here I get limit as x goes to 0, e to the x over 2. This function is continuous everywhere, right? Is continuous everywhere, right? Because I'm not ever dividing by 0. If I plug in any number, then I have a continuous function. Since this function is continuous everywhere, we can plug in 0. So this is just e to the 0 over 2, which is just 1/2. And that is how to do this problem. As always, if there's questions, I will be on Discord during the appropriate times. But for now, take a picture if you need, or a screenshot, or this is a video, you can just come back to this whenever you want. And let's move on to the next problem. Problem 2, where I just ask you to take the derivative of the following. Now in this case, it's not too hard to take the derivative because you can just literally multiply things out. It'll be nasty and disgusting, and then you can take a derivative of the big polynomial. In this case, this is probably not what you're going to want to do with what's on the exam. So I'm going to actually show you what you should be doing, even though it's going to look a little convoluted for this example. Like I said, I'm just choosing easier examples for life to be a little easier, so we can fit everything in a smaller amount of time. So for this one, you're going to probably want to use logarithmic differentiation. And I see this because I have a lot of exponents. So because I have a lot of exponents, I want to bring them down. And so the best way to do this is kind of like how we did the very first problem, in that we took the logarithms of both sides. So let's do that. We take natural log of y is equal to the natural log of this whole exciting thing, right? And here you're going to want to remember the rules of natural log. And that's if I multiply things together, they're actually added outside. If I divide them, they're subtracted. And if I have an exponent, I can bring it in front. So here, this is actually, so remember you want to show steps. So this I can break down into x4 plus 4 to the 4 plus, why am I there? ln of x squared plus 2 squared. So here I have 4 ln of x4 plus 4 plus 2 ln x squared plus 2. And I can't do any more, right? I can't separate addition. So that's it. I'm stuck here. So here I'm going to now take the derivative. So let's take the derivative of both sides with respect to x. This here is equal to the derivative of y, and then the derivative of y with respect to x, because y is a function of x, right? And so on the right-hand side, I have the derivative of 4 natural log of x to the 4 plus 4 plus 2 ln x squared plus 2. And so what do we have? So here we have, so this is, we have an addition, so I can do this first part first. I just have 4 times the natural log, so I take 1 over that, and then I multiply by the derivative of the inside, which is just 4x cubed, right? On the right, I have almost the same thing, except here I have 2. I have x squared plus 2, so the derivative of natural log is 1 over the inside is x squared plus 2. And then I take the derivative of this, bring it up, so times 2x. So here I have 16x cubed over x to the 4 plus 4 plus 4x over x squared plus 2. And in this case, I would just leave it like this, and then just merge these two together. So we have dy over dx, 1 over y, is equal to 16x cubed over x4 plus 4 plus 4x over x squared plus 2. So we end up getting dy over dx is equal to y times 16x cubed over x4 plus 4. Oops, not yet. Plus 4x x squared plus 2. And then we know what y is, right? Y was our original function, right? So up here, I have my y. So I can plug in my y into my function down here. So this is nothing more than x4 plus 4. Let's see if I remember this properly. X squared plus 2 squared times 16x cubed over x to the 4 plus 4 plus 4x over x squared plus 2. And this should be okay. This should be an okay answer. We'll make this little sticker. Yay! So that's question 2. As always, if you have questions, feel free to ask. Let's move to question 3. And here we're looking at a function, one of the quiz questions, basically, right? So we saw this question in the quiz, and a lot of people had difficulty with it. So we're playing around with it and seeing if you all understood kind of what's happening, whether you understand when something is a function of something else. So remember that since s is a function of r, we can think of s as some function of r. So this is equal to something where there's r's inside, where there's r inside. I don't know what the function is, but for us, I don't really care, right? So now what we're going to want to do is we're trying to find ddr of s. So let's take ddr of both sides, and let's see what we get. dr 12. So this right-hand side is easy. This is just equal to 0. The derivative of a constant, no matter what our variables are, is always 0. This looks like a horrible S. There we go. Here, it's a little more difficult, right? And this is what's going to be difficult for the exam. What does this part equal? So here, we're going to first take the derivative. And the derivative of the exponential is easy, right? So you keep the function itself. And then you take the derivative of the inside. And I'm going to do this in steps just to make life a little easier. So the inside is just r squared s. And this is equal to 0. So here, I'm going to move this 0 to the other side so I can just work one after another. So here, what do we get? As you notice here, this is exactly almost like what we had for the quiz. So I take the derivative of the first part. So I have 2rs. And that's because the r here, it's already in with respect to itself. So I don't have to do anything else. This is okay. And then here, I'm going to keep my first part, and then I take the derivative of the second part. But here, s is a function of r, and I don't know what s is. So I'll have to take the derivative of s with respect to r. And this is where this becomes a derivative in itself. And so what we end up getting is er squared s times 2rs plus er squared s r squared ds dr. But remember, we're trying to solve what this is. So let's solve this. So this is equal to 0. So we get minus e to the r squared s. I'll bring the 2 in front. rs here is equal to e to the r squared s r squared ds dr. And so minus 2. So now I need to divide kind of this part here. R squared s rs divided by er squared s r squared is equal to ds dr. We're almost done. Notice here I can do some cancellation. So this part cancels with this. This r cancels with this r. And so I get ds over dr is equal to minus 2s over r. And so that's what we end up getting. So notice how this is a lot easier than our original formula. All right. So let's keep going. Next question.